All right, we're going to move into our new unit, which will cover igneous and metamorphic rock. I want to go back and talk about rock itself. Remember that minerals are chemical compounds, whereas rocks are actual physical mixtures, mostly of minerals. Looking at a rock, you can sometimes actually see the mineral crystals in it. You can pick it up and you can see many different things in it. Granite is the most common type of rock on the Earth's continental crust. And you can look at granite and see many different types of minerals in it. So we're going to talk about also the difference between rock versus soil. Soil is basically dirt, and when you look at dirt, it's a mixture of small bits of crushed rock and also organic matter. Okay, so the soil that we use for planting plants and stuff does have organic matter in it. It's important that it have a whole bunch of different compounds in it in order for plants to grow. Igneous rocks actually form very specifically from magma that's either in the Earth's crust or that's being released from volcanic activity. And magma and igneous rocks themselves cool and crystallize, which is how they become rock. Magma, it's important to remember, is melted. It's completely liquid and melted until it reaches the Earth's surface. Igneous actually means formed by fire. Basalt and granite are two very common igneous rocks that we have here on the Earth's surface. So when magma cools and solidifies, that's how igneous rock is formed. Not metamorphic rock. Igneous rock is formed that way. It's when rock has been liquefied. It has to have been liquefied in order for it to cool and be considered igneous. Magma is produced when the rocky material of the Earth's solid interior partially melts. There are three factors that have to be considered when magma melts. First of all, there is a high temperature, obviously. The second thing is pressure. So we've talked about before the fact that it doesn't matter how high pressure is, often, or how hot something is. It's the pressure itself that can keep atoms packed so closely together that they can't move freely like they would as a liquid. Therefore, within our Earth's core, it's under such high pressure that despite the temperature, we have solids that form. So one of the factors, in addition to high heat that's necessary for magma, is the addition of water, which we know occurs at things like subduction zones and divergent boundaries, all of that sort of stuff. We know that there is the addition of water. But the third thing is the decrease in the localized temperature. So we know that conduction occurs in the Earth's mantle. We have something heats and it rises. It cools and is dropping. As it's cooling, it gets more closely packed together. As it rises, it loosens up. So it's as it rises and it gets closer to the top and the pressure decreases that we have that magma that's able to form. When that magma is released, either extrusively, meaning out of, so it's erupting either from a divergent boundary or it's coming through the top of a volcano. That's called extrusive igneous rock. Intrusive igneous rock is where that magma pushes into and between crevices, holes, caverns, anything like that, and is able to solidify, but it remains internal. Intrusive meaning into. So as that magma comes out and it cools, several different things can happen. So there are many different types of igneous rocks. So the question is, does that mean there are several different types of magma? And the answer is not really. There's basically only three different types of magma. And those different types of magma are basaltic, andesitic, and granitic. However, with those three different types, one of the key components for how magma cools relates to what's formed after that. So, and these, by the way, these magmas are found in different tectonic settings. And we've studied tectonic plates enough for you to understand that in different parts of the world, you're going to have different types of rock and mineral compositions. So that would be how different types of magmas might form. So one of the things that's important to note is there are basically 4 different ways that we look at how we classify igneous rock. The first one is coarse grained, and that is where the crystals form so that you can see them. There's a type of rock in Maine which has got such large crystals that they can almost be the size of your hand. They're extremely large, easy to see. We also have very fine grained, and that is where the crystals forming are so small that you'll actually need a microscope to see them. The third part is glassy, and believe it or not, there's a form of obsidian rock which has no crystals at all, but it is still considered igneous, and it has a glassy appearance. It looks like black glass, basically. And then finally we have the porphyritic, which are where the crystals are more than one size. And that might be because as the magma cools, you're going to have some rapid cooling followed by slower cooling. All right, so what's important here to take away, and I need you to put these details into your notes, please, is that slow cooling magma produces igneous rock with large crystals. So the slower magma cools, the larger the crystals are. Rapid cooling produces small crystals. The faster it cools, the more rapid there is. But then we've got this third phenomenon where we have instantaneous cooling, and that's where no crystals form at all, and that's where the igneous rock forms a glassy texture like obsidian. All right. Other things to remember is when we talk about fast or slow, fast cooling could be months, because remember what a high temperature magma actually is. The rule of thumb is that rock increases by 30 degrees Celsius for every kilometer it gets closer to the Earth's core. So for every kilometer down, the temperature of that rock is going to increase by 30 degrees Celsius. And if you're not used to Celsius temperatures, 30 degrees Celsius is pretty hot. It would be about 110, 115 in Fahrenheit. So it's pretty hot. Remember the 3 different issues that we have in terms of the formation of igneous rock: high temperature, decreased local pressure, and the introduction of water. Those are all needed for igneous rock. The other key factor that you want to think about is that igneous rock can only form from magma. It has to have formed from melted rock. It can't form from sedimentary rock. It has to have formed from a liquid rock, so magma. All right? Next video will be on metamorphic rock. If you don't understand anything at all about this video, I'm new to this stuff, remember, give me some feedback and let me know what I can do to make them better. All right, bye.